Hello viewers, in today's session we are going to discuss an important and conceptual problem from limits, right? And in this class we are going to discuss the limit, that is limit x tends to 0, and here the function is the greatest integer of x minus mod of x divided by the fractional part of x, right? So the important thing about this limit is that we have three important functions of mathematics, that is the greatest integer function, the mod function, and the fractional part function, right? So here we have to discuss the existence of this limit when x tends to 0, right? So for the existence of limit of a function at a given point, what we do, we first find the right hand limit and then we find out the left hand limit, right? And both the limits, the right hand limit and the left hand limit, should exist, and they should be finite, and moreover the right hand limit must be equal to the left hand limit, right? So we'll find out the right hand limit and the left hand limit. So here we have to find out the limit when x tends to 0. So let us draw the real number line, and here we have the point that is x is equal to 0, right? So when we approach x is equal to 0 from the left, then we have a point in the neighborhood of x is equal to 0, and this is called the left neighborhood, and this point is 0 minus h, right? And when we approach from the right of x is equal to 0, then we have a point in the right neighborhood of x is equal to 0, and this point is 0 plus h, right? So this distance is h, and similarly this distance is also h, right? So the right hand limit, or the notation for the right hand limit, is given by limit, and here we write x tends to 0, here we write positive sign, and here we have f of x, right? Where f of x is given by this function, that is greatest integer of x minus mod of x divided by a fractional part of x. So here I will make use of the definition of fractional part function. So the fractional part of x is defined as the difference between x and the greatest integer of x, right? So when we substitute this value of fractional part of x over here, our function f of x, it takes the form that is the greatest integer of x minus mod of x divided by x minus greatest integer of x, right? Okay, so now here the notation for the right hand limit is given by this notation. So we'll take x is equal to 0 plus h, right? So we'll make this substitution, x is equal to 0 plus h, where this h is a very small quantity, which is also known as infinitesimally very small. So h is infinitesimally very small, but it lies between 0 and 1, implying that this h is a positive quantity, right? Okay, so now we take x is equal to 0 plus h, it means this is h, and when x tends to 0, then obviously h also tends to 0, right? So now transforming this limit in terms of h, we have a right hand limit equal to limit, we have h tends to 0, and here we have f of h, right? Because x is equal to h. Now we can write limit h tends to 0, and f of h can be obtained by replacing x by h in f of x. So we have greatest integer of h minus mod of h divided by h minus the greatest integer of h. So here we have h, right? So now we have to evaluate this limit, right? Now see, whenever we have the greatest integer function, then we cannot directly substitute h is equal to 0 over here and here, right? So what we do, we make use of the definition of greatest integer function. Now see, h lies between 0 and 1. So here we have 0 and here we have 1, right? So our h, it lies between 0 and 1. So by definition of greatest integer function, the greatest integer of h should be equal to 0, right? So here for greatest integer of h we can take 0. So now this limit becomes limit h tends to 0. Here we have 0 minus mod of h is equal to simply h, because h is a positive quantity, and then here we have h minus 0. So now simplifying it, we have limit h tends to 0. This is 0 minus h, that is minus h. This is h minus 0, that is h, and this h get cancelled. So we have simply minus 1, right? So the right hand limit of this function when x approaches to 0 is given by minus 1. So the right hand limit is minus 1. Now let us calculate the left hand limit. So now the notation for the left hand limit is given by limit, and here we have x tends to 0 minus, and here we have f of x, right? So here we have the point in the left neighborhood, that is 0 minus h. So we'll take x is equal to 0 minus h. So we'll make this substitution, x is equal to 0 minus h, that is minus h. So when x tends to 0, then obviously h tends to 0. So now writing this limit in terms of h, we have left hand limit equal to limit h tends to 0, and here we have f of minus h, because x is equal to minus h, right? So we have limit h tends to 0, f of minus h can be obtained by replacing x by minus h. So here we have greatest integer of minus h minus mod of minus h, and here we have minus h minus greatest integer of minus h. So now again we have the same situation. We have here the greatest integer function, and we cannot directly substitute h is equal to 0, right? Now see, here we have to find out the value of greatest integer of minus h, right? And see, h lies between 0 and 1. So when we multiply this inequality throughout by minus 1, we'll get this one, that is 0, and the direction of the inequality get reversed. So here we have minus h, then we have minus 1, and we can rewrite this inequality as minus 1 minus h and 0. So this inequality suggests that minus h lies between minus 1 and 0. So here we have minus 1, right? So our minus h, it lies between minus 1 and 0. So by definition of greatest integer function, whenever we have a number lying between minus 1 and 0, then the greatest integer of that number should be equal to minus 1. And here we have mod of minus h, which is simply a positive h, right? So now this limit takes the form limit h tends to 0, and here we have for greatest integer of minus h we have minus 1, and here we have minus, and for mod of minus h we have positive h divided by minus h, and here we have minus 1, right? So we have limit h tends to 0, and here we have minus 1, then we have minus h, and here we have minus h plus 1, right? So now taking the negative sign, common here, we can now write limit h tends to 0, and we have minus 1 plus h divided by 1 minus h, right? So now taking h is equal to 0, so we have minus 1, here we have minus 1 plus 0, and here we have 1 minus 0. So this is minus 1 over 1, that is equal to minus 1, right? So the left hand limit of this function when x approaches to 0 is also equal to minus 1, right? So viewers, from this discussion, we have seen that the right hand limit is equal to minus 1, the left hand limit is also equal to minus 1, and both these limits are finite and they exist, and moreover, they are equal, right? So the right hand limit is equal to the left hand limit, that is equal to minus 1. So we can claim that this limit is equal to minus 1, right? And we can say that the limit of this function when x approaches to 0, it exists and it equals to minus 1. So this is how, by making use of the concept of right hand limit and left hand limit, we can prove the existence of limit of a function at a given point.